Today's lesson is a continuation of 6.1. It's about making connections with the area function that we've been working on through Riemann sums, getting approximations, all the way through the definite integral that we did on the graphing calculator, to now making the connection about what is this area function, how is it connected to something from our past, which is the derivative. So to start us off, we're going to be given some functions on a specified domain where one endpoint will be a given number, the other endpoint is open. So we say from A to X. A is a definite number where we start collecting area, X is open-ended. Our job is going to be to confirm that the derivative of the area function gets us back to the original function, showing the cycle of how the derivative and the area function are connected and are inverses of each other. So we have our function f of x is equal to 2, so I have my horizontal line at 2. I start collecting area at an a value of 1, so I draw a vertical line at 1, and again, just like with the Riemann sums, I stop at the x-axis. I go to this x value. X can be anywhere you want, so when you're drawing it out in the homework, you just go somewhere to the right of 1, drop down, and then call it x, anywhere you want. To find area, you look at your shape. This shape is a rectangle. Rectangle's area is found by taking your base length and multiplying it by your height. In our case, our base length is the difference between the right minus the left, which is x minus 1. It gets multiplied by the height of the rectangle, which is 2. If I multiply those together, I get my area function, which is 2x minus 2. Then, this is the very cool connection. If I take the derivative of my area function, which, by the way, this area function would find the area for any rectangle that you want to create that starts at 1 and goes somewhere to the right. So if you wanted to find the area from 1 to 5, I would plug in 5, and then I would get my area. If I wanted to find it from 1 to 3, I would plug in 3, and I would get the area. So that's the purpose of this area function. It's finding the area from 1 to wherever. Now note, if I take the derivative of my area function, the derivative of 2x minus 2 is just simply 2. But note, the original function, the original f of x, was just 2. Look at that connection. The derivative is matching the function back itself, circling around. Our next example, we're going to graph the line x plus 1, and in the homework you're going to have to do the graphing and also drawing the pictures. I did it ahead of time so it would flow a little smoother. So we have x plus 1, our line, and then I'm starting the collection of area at 2. So I have a vertical line at 2, going somewhere to the right, call this value x. I want to find the area of my shape. Well, this shape happens to be a trapezoid. So I have to remember area in a trapezoid from geometry is half the height times the sum of the bases. Okay, the height is down here along the x-axis because the height is perpendicular to the parallel segments. The parallel segments are the bases. So I've marked it base 1 and base 2. Now what we're going to do is we're going to figure out what is the representation of the height and the bases. So the height right here is along the bottom, kind of similar to the rectangle. So if I take the right minus the left, x minus 2 represents the height of this trapezoid. Base 1 is this length right here, which is at an x value of 2. I go up to my formula, I plug in 2. 2 plus 1 is 3. Base length of base 1 is 3. Base 2, however, is not a definite length. I put my x here. You could put your x here. You could put your x here. All of our x's could be in different spots. We could all have different sized trapezoids. Again, this is finding the area of a trapezoid starting at 2 and going somewhere to the right. So my next base is in terms of x. So since it's in terms of x, I go back up to the formula and say, if I'm plugging x into itself, then to find its height, I simply take x and add 1. So x plus 1 is base 2. Then we do a little algebraic manipulation. Multiply those together after I simplify the 3 and the 1 to get 4. Multiply them and I get this. And multiply again by a half. I've got my area function. Then the neat connection, derivative of the area function. Take the derivative, 1/2 x squared becomes just x. Derivative of x is 1. Derivative of a constant is 0. So note, where have we seen that before? Well, what is f of x? F of x is x plus 1. So the derivative of the area function gave me back the function itself. 2 more examples. Whoops. Whoopsie. I bet you missed that word since you've been gone. And also made a boo-boo. All right, where's my tape? Oh no, it's being used for the camera.
Yeah.
I'm gonna have to free float it. Oh, hold on, a little adjustment here. Thank you, my assistant, Colby. By the way, my son's learning a lot of calculus here today and all the other videos. The next one, f of x equals 2x. We start at 0, rising 2, running 1. So my line is 2x. I start at 0, here I am at the origin, going somewhere to the right, x units away, forming a triangle here. Area in a triangle is 1/2 base times height. So I need the base. In this case, the base is just from 0 to x. That's a distance of just x. The height of my triangle, again, it's over here on the right, so it's non-specified. It's some x value. So I have to go back up to my formula and say, if it's the x value, then it's the height at that x value. Well, this height is the height of the function. The function is 2x. I'm putting in 2x. I total that up. My area function is simply x squared. And guess what we're going to do next? We're going to take the derivative, and voila, we should get back. I know you're guessing it. You're just waiting for me to say I'm getting f of x is the same thing as the derivative of the area. Last one. F of x is 4x minus 2. I got my line starting here at -2, going up 4 over 1 each time. So there it is in red. Again, I'm forming a trapezoid. I'm starting at 1, going to x. Again, put your x somewhere to the right. It doesn't have to be the same as mine. The bases are the ones that are parallel to each other. Height is perpendicular. So I'm going to start filling in. 1/2 height. Guess it before I do it. Is everybody guessing x minus 1? I hope so. I'm plugging in for base 1. So I'm going to take the 1. Guess it, guess it, guess it. Plug in the 1. 4 minus 2 is 2. Plus base 2. Take a moment. What are you thinking for base 2? I hope you're getting 4x minus 2, and we're matching. Okay, then we're doing the simplify like we did before. So here's a of x being simplified, more simplification. Final simplification, I get the area function, which is 2x squared minus 2x. Guess what? Taking the derivative, 4x minus 2. And wait for it, what's the original function? It's 4x minus 2. The nice thing about these problems is you know if you've done them correct because you always circle back to the original problem, which is a very cool thing. Hope you have fun doing the homework problems. Thanks for listening.